Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this interesting problem. So let's get started. Alright, let's see this problem. In this problem we are given a binary array and our task is to find minimum consecutive flips to make all the elements same. And here there are two things we should keep this in mind. First thing is we are allowed to flip all zeros at once or all ones at once. It means either we can flip all the zeros to 1 or we can flip all the ones to zeros. And second thing to note here is we are allowed to do consecutive flips. If the array is given as 1 0 0 0 1, then we can allow to flip all the 0 in one go. Okay, so now let's understand this problem with few examples. So here you can see that the array is given as 1 1 0 0 1. So here we have two options. Either we flip all the ones, and if we flip all the ones, we have to flip ones from 0 to 1 and 4 to 4. It means the 4 index and 0 to 1 index. And if we flip zeros, then we only have to flip zeros from second index to 3 index. And the minimum of both are 2 to 3. So the output of this input is going to be from 2 to 3. Let's see the next example. Here the array is given as 1 0 0 0 1 0 0 1 0 1. Now if we consider ones, we have to flip 1 on 0 to 0, 4 to 4, 7 to 7 and 9 to 9 because the 1 present at index 0, 4, 7 and 9. But if we consider zeros, then we have to flip only 3 times, from 1 to 3, then from 5 to 6 and from 8 to 8. And the minimum of both is 3. So minimum we need 3 consecutive flips to make all the elements same. Okay, now let's see the next example. Here we have 1 and 0. So here we can either flip 1 to 0 or 0 to 1. It's up to you. So the output could be anything from 0 to 0 or from 1 to 1. In next example, the array is given as 1 1 1 1. So here we do not need to flip any number because the array contains only 1. In next example, here you can see that all are zeros. So here also we do not need to flip any numbers because the array contains only zeros. We only have to flip the numbers if that array contains combination of 1 and zeros. So I hope now you have a good idea about this problem. So let's pause the video and think about an algorithm to solve this problem. Moving on. So let's first see the brute force approach to solve this problem. So the idea of brute force is pretty simple. First we have to traverse an array from left to right, and while traversing we have to count number of groups of zeros and ones. And then we have to flip all the bits of the smaller groups. Okay, for example, let's say in this array there are 2 groups of 1 and only 1 groups of 0. Okay, so we have to flip the elements of group that has minimum count. So in this case we will flip all the zeros to 1 to make all the elements same. So this is the basic idea of brute force approach. Now let's see the implementation of this basic approach. So here we have a function minimum consecutive flips, and this function is taking arrays input. So first we are initializing 2 variables, zeros group and ones group, and this 2 variable is going to help us in counting number of groups of 0 and number of groups of ones. Okay, and we are storing the first element in the previous variable. Okay, and we are checking if the previous element is equal to 0, then we are incrementing zeros group by 1. If not, then it must be 1. So we are incrementing ones group by 1. It means it is the starting of the zeros group or ones group. Okay, then we are running a loop from next element till less than n, and we are checking if the element we are traversing is 0 or not. If it is 0 and if it is not equal to previous, then we are incrementing zeros group by 1. Okay, it means now we are facing the new group of zeros and assigning the current variable to previous variable. Okay, in next if condition we are checking if the current element we are visiting is 1 or not. If it is 1 and the array of I is not equal to previous, it means here we are getting new group of ones. So we are incrementing ones group by 1 and assigning the value of ARR of I to previous element. Okay, so this is how we are finding count of groups of zeros and 1. And after this loop, we are assuming that the count of group of element 0 is 0. And if it is not, count of ones group is less than zeros group, it means the element is 1. So this is the element we need to flip. And then this is the code of flipping all the bits. So basically if zeros group is less, then we are flipping 0, and if ones group is less, we are flipping 1. So first of all, we are checking if the first element is equal to element or not. If it is equal to element, then I am printing just from. Okay. And then we are running a loop from 1 to less than n. And in this loop, we are checking if the current element is element or not. If it is element, then again we are checking if previous element is not equal to element or not. And why we are doing this? To find the beginning of the group. And in next if statement, we are finding the end of the group, so that we can print 2 on the screen. And in the last, we are checking the last corner case. If our last element is equal to element supposed to be flip or not. If it is, then we are simply printing 2. So this is all about the function. I hope it is difficult to understand. So let's quickly try run this code and see how it works. So let's say the array is given as 0 0 1 1 0 0. Our zeros group is 0 and ones group is also 0. Our previous is equal to 0. Means we are taking this element and store it in the previous element first. And then we are checking if the previous element is 0 or not. Here in this case, previous element is 0, means it is the starting. It means it is the beginning of zeros group. So we increment zeros group by 1 and keep ones group as 0. Now the loop begins iteration from I equal to 1. We come over here and we check if this element is same as previous or not. And it is same as previous, so we are not doing anything. In next iteration, the value of I becomes 2 and 2 is what? 1. So this condition is going to work here. So it checks if array of I is 1, okay, this time it is 1 and it is not equal to previous one. It means it is the beginning of new group and that is 1. So we increment ones group by 1 and assigning this 1 to the previous variable. In next iteration, the value of I becomes 3. The value presented index 3 is 1. So we check it is equal to previous or not. It is equal to previous, so we are not doing anything here. Then in next iteration, the value of I becomes 4. Element presented index 4 is 0 and 0 is not equal to previous. So we increment zeros group to 2 because it is the beginning of zeros group. Okay, and we store the value of the element presented index 4 to previous variable. Now moving to next iteration, when I becomes 5, the element presented index 5 is 0 and it is same as previous. So we do not do anything and the value of zeros group comes out to be 2 and ones groups comes out to be 1. So the smallest out of both is ones group. It means we have to flip ones to make all the elements same. Okay, so after this for loop, the execution begins from here. And here first we are assuming that the element needs to be flip is 0. And if one's group is less than 0, then the element needs to be flip is 1. Okay. So here as we can see that the ones group is less than zeros group, it means we have to flip all the ones. So the value of E is going to be 1. And then we are checking if the first element of the array is equal to element or not. In this case it is not. So we are not printing from. Then we are running a loop from 1 till less than n. And in the first if condition we are checking if this value is equal to element or not, and this is not the case. Okay, so we move to next condition. In next condition we are checking if this is not the element, and this time it is not the element, it is not equal to the element. So again we are checking one more condition, that if ARR of j-1 is element or not. Okay, but this time the ARR of j-1 is not equal to element. So after this if condition, in next if condition we are checking if the ARR of j is not equal to element or not, and this time ARR of j is not equal to element. Okay, the first condition is true, but next condition is ARR of j-1 is equal to element, but ARR of I-1 is 0. 0 is also not equal to 1. So we move to next iteration. So both the conditions are false, so we move to next iteration. In next iteration the value of j becomes 2. Okay, now value of j becomes 2. In second index we have 1. Okay, so we are checking if ARR of j is equal to element. Okay, this time element is equal to 1 and ARR of a j-1 is not equal to element. Okay, it means the previous element is not equal to 1. This is also correct. So in this case we are printing from value of j. Value of j is 2. Okay, then in next if condition we are checking if ARR of j is not equal to element, it is equal to element. So this condition becomes false and we move to next iteration. In next iteration the value of j becomes 3. At index 3 we have 1. We again check it is equal to element. We again In if condition, we again check if it is equal to element. Yeah, this time it is equal to element. But the second condition becomes false because the previous element is also equal to element. So we simply skip this iteration. In next iteration, the value of j becomes 4. Okay. And now this time we check if the array of j is equal to element. This time it is not. So we move to next if condition. And this time the value of ARR of j is not equal to element because this is 0 and this is 1. So we continue to next condition, that is ARR of j minus 1 is equal to element. This time ARR of j minus 1, that is 1, is also equal to element. So we print 2 and the value of j minus 1. J minus 1 is 4 minus 1, 3. So this is how it gets printed on the screens, that we have flipped all the ones from 2 to 3. Okay. So this is how this entire piece of code is going to work, and this is a very lengthy code, I guess. Okay, so far so clear. Now talking about the time complexity, how many loops we are running. On the top we are running one loop and below we are also running one loop. So, and both the loops are running n times. So in total it is running 2n times. And in asymptotic analysis, we simply do not care about constants. So the time complexity came out to be big of n and the space complexity came out to be theta of 1. So far so clear. Now the challenge here is to how to solve this in one traversal. Here we are making two traversal of the array. First we are traversing here and second we are traversing here. First is to find the group of zeros and ones and second is to flip all the bits. So think about it and try to find a solution that can solve this problem in one traversal. Alright, so now let's talk about the efficient approach to solve this problem. But before we move on to the efficient approach, here we have observations to be made. The first observation is we are given a binary array. It means there are two possible values that can exist in the array. One is 0 and other one is 1. So the given array never contains any element that is other than 0 or 1. Okay. This is the first observation. So now let's consider this binary array, this and this. Now here you can observe that the number of groups of zeros is 2 and number of groups of ones is also 2. And if you consider this array, here the number of groups of 1 is 2 and number of groups of 2 is also 2. It means the count of groups of both the binary array is exactly same. Okay. Now in this case we can either flip 0 or 1, it doesn't matter at all, right? So this is our first observation. Now moving to next observation, if we have array like this 1 1 1 1 and 0 0 0 0. So here you can see that the count of group of ones and 0 differ by 1. Why? Because the count of group of 1 here is 1 and count of group of 0 is 0. So 1 minus 0 is equal to 0. And here the count of group of 0 is 1 and the count of group of 1 is 0. So here also 1 minus 0 is equal to 1. But here as we can see that all the elements are 1, so we do not have to flip any bits. Okay, and here also we do not have to flip any bits to make all the elements same. Now moving to next example. Now this is where things gets tricky. Here if you see this binary, you can see that the count of group of 0 is less than count of group of 1. So it means we have to flip zeros to get the minimum consecutive flips, right? And one more thing to notice here, that this binary is beginning with 1 and ending with 1. Okay. And here in the above example we just talked about is here the binary starts from 0 and ends with 1. Okay. So if this is the case, then we do not have to care about ones or zeros. We can flip any bits, either 1 or zeros. But if the binary is given as like this and it is beginning with 1 and ending with 1, we have to think about it and we have to find the minimum count of groups. Okay. In next example, this binary array begins with 0 and ending with 0. And here the minimum count of group is 1 and the count of 0 is more than 1. Okay. But if you look at both the binary array, you will realize that if we flip the second group of elements, then we always get the minimum consecutive flips. You can see this clearly. If we flip the elements of second group, we can always get the consecutive flip. Now the question over here is, what if we add more ones and zeros at the end of this binary array? Okay, let's try it. If we add 0, so now the count of group of 1s becomes 3 and the count of group of 0 becomes 3, and the minimum of both is differed by 0 only. So both become 0. Now this array is exactly look like this array, where the count of group of 1s is equal to count of group of count of group of zeros. Okay. Now again you might ask that what if we add 1 to it? Then also, and then what happens? The count of group of 1 becomes 1, 2, 3, 4, and the count of group of zeros become 3. So this time the difference is of only 1. And this time also, if we consider second group of elements, we get the minimum consecutive flips. Okay. Now this is happening. So the same thing happens with this array also. If we add 1 to it, then the count of group of 1s is 3 and the count of group of 0 is also 1. So it is the same as the previous example. And what if we add 0 to it? Now you can see that the count of 1s becomes 1, 2, 3 and count of group of 0 becomes 1, 2, 3 and 4. Okay. And still if you consider this second group of element, we get the minimum flips. In this case we just have to flip these elements, this and this. So 3 flips we need. Okay. So by looking at all the examples and by all the observations, we can conclude that in all the cases, if we consider only the second group of elements, then we get the minimum flips and it will handle all the cases. So far so clear. Now the question over here is how to find the elements of second group. So let's consider this binary array 0, 0, 1, 1, 0, 0 and 1, 1. Okay. So in this binary array, first observation is it's begin with 0 and ends with 1. And if we have to find the elements of second group, we can easily find it. Let's see how. Okay. So let's consider this element. This is the beginning of the second group. Okay. So if you compare this element with the first element, you can see that this is 1 and this is 0. It means this is the beginning of the second group. And if you consider this element and if you compare with the element at the position first, you can see that this is the end of this second group. Okay. Moving on to next group. Again, if you compare this element with the first element, you can see that both are different. It means it is the beginning of the group that contains the elements same as second group. Okay. So you can see that this is how we are going to find out the beginning and the ending of the second group and the elements of the second group, so that we can get the minimum flips. So the idea of this efficient approach is pretty simple. We have to traverse an array from left to right and flip elements of the second group only and print the range of all the flips. So let's quickly see the implementation of this approach. So here we have a function minimum consecutive flips, and this function is taking array as input, and we are running loop from 1 till less than n, and inside this loop we are checking if array of I is not equal to array of I minus 1. Okay. If array of I is equal to array of I minus 1, then we do not have to do anything. We just have to continue the iteration. Okay. Inside of this loop we again have if else statement, and in this statement we are checking if array of I is not equal to ARR of 0, and this if statement find out the beginning of the group. Else we have to simply print 2 to indicate the end of the group. Okay. And the last statement is the if condition. I will talk about it in a bit. So this is a simple function. Let's quickly try run this code and see how it works. So here the array is given as 0, 0, 1, 1, 0, 0. Our loop begins and we start our loop with index 1. In first index we have 0. So in first index we have 0. We check if it is equal to previous element or not, and this time it is equal. So we simply skip the iteration. In next iteration the value of I becomes 2, and now the value present at index 2 is 1. Now this time this element is not equal to previous element, so we get into this if statement. In inner if statement we are checking if this value is not equal to the element at index 0, and this time it is not equal to. It means we got the first element of the group that needs to be flipped. See, we do not have to do anything if the previous element is same. We only have to react when previous element is not equal to the current element, right? It means it is a group that needs to be flipped or it is a group that needs to be skipped. So we simply print from 2. Moving to next iteration, now the value of I becomes 3. And this is also not same as the first element, so we simply ignore it. Now in next iteration, the value of I becomes 4. Now you can see that this element is exactly same as the first element. So it means it is the end of group. Okay, so we are printing here 2 and the value of I minus 1. I minus 1 is 3. So this is how we are finding the group of all the ones, or I could say we are finding second group and elements of second groups. It could be anything. It could be group of ones or it could be group of zeros. In next iteration, the value of I becomes 5. Moving on, in next iteration, the value of I becomes 5 and we get a 0. So in this case, we check if the previous element is same. It is not, it is same. It is same. So we do not have to do anything. And so finally the output of this input is from 2 to 3. So we have to flip. So we have to flip all the bits from 2 to 3 to make all the elements same. So talking about the last statement, you can see here if array of n-1 is not equal to array of 0, this statement is just to handle the corner case. Let's say we have got an array like this 0, 0, 1, 1 and now we have to flip all the ones. So what happens? As per this program, it will print from 0, 1 to 2. Okay, but when it comes here, then loop gets terminated. So we end up printing only from, but we have to print 2 also. So in this case, we check if n-1, this element is not equal to this element or not. If this is the case, we simply prints 2 and the index of this element, that is n-1, 0, 1, 2, 3. So this is the corner case we are handling using this if statement. So far so clear. Now talking about the time complexity of this function, here we are running only one loop. So that is why the time complexity comes out to be big of n. And the space complexity comes out to be big of 1 because we are not using any auxiliary space here. So to solve this problem, this approach took big of n time and big of 1 constant space to solve this problem. So finally we have done it. We have solved this problem in single traversal. So far so clear. So before we end this video, let's have a quick recap of what we have done so far. So in this problem, we were given a binary array and our task is to find minimum consecutive flips to make all the elements same. To solve this problem, we saw the brute force approach. And in this approach, we are solving this problem with 2 traversal. So the time complexity came out to be big of n. After brute force approach, we saw the efficient approach to solve this problem. And in this approach, we are only traversing array one time. And the time complexity of this function is also big of n. But this is a more efficient approach and it requires less piece of code to solve this problem. So I hope now you have good understanding of how to find minimum consecutive flips in a binary array. So this is it for this video. Thanks for watching. See you in the next video.